example, given the circle R equals 3 times cosine theta and the cardioid R equals 1 plus cosine theta, part A, we're going to find points of intersection, and part B, find the area of the region outside the cardioid and inside the circle. Find the point of intersection by equating both R's together. So POI, or the point of intersection, equate those to R. So 3 cosine theta equals 1 plus cosine theta. Simplify, adding cosine theta, subtracting cosine theta both sides, we get 2 times cosine theta equals 1, or cosine theta equals 1 over 2. The cosine is positive. It will occur when the theta in quadrant 1 and quadrant 4. Then the theta is pi over 3 or 60 degrees, and in quadrant 4 would be 5 pi over, no, sorry, pi over 3. So 5 pi over 3. So the theta pi over 3 and 5 pi over 3. The graph of the circle R equals 3 times cosine theta, and the graph of the cardioid R equals 1 plus cosine theta will meet at pi over 3 and theta equals 5 pi over 3. So let's use the graphing calculator to help us see the better picture. Again, make sure the calculator is set in the polar mode. Go to y equal, type in the first equation, which is the circle, or r equals 3 times cosine theta, 3 times cosine theta, and see what the graph looks like. It looks like the graph, the center is shifted to the right. From our notes, let's draw it. And then how about the cardioid? For the cardioid, we type the equation R2 as 1 plus cosine of theta, and then sketch the graph. The smaller part is the cardioid. Let's see, to confirm, if we omit the first one and see the graph of just the cardioid, so it's kind of sideways. The left part, it has like the dip back into the zero and go back out again, and the longer part is on the right side. So the graph will be something like that. Now confirm with the graphing calculator, put both of them together. So move the cursor and make sure it's highlighted at the equal sign by put the equal sign. Now see the graph. So those two kind of overlapping with each other. Now we're gonna find, we already got the points of intersection. Next, we're gonna find the area of the region outside of the cardioid, but inside the circle. So gonna be the one that's outside cardioid, inside of the circle. These two, both graphs have symmetry with respect to the x-axis. So we use the concept again, multiply 2 to a half of the region. So this case start at theta equals 0 to theta equals pi over 3, and then multiply by 2. So the area equals the definite integral starting from 0 to pi over 2, but multiply by 2 because we do twice of a half of the region. The integrand is 1/2. Now we're gonna determine which one has the longer radius or longer r. The longer r squared minus the shorter r squared with respect to theta. For our case, the longer r, if you take the ray or the r from the pole, we can see that the longer one is the circle and the shorter one is the cardioid. So then we can set it up as a equals sin 2 and 2 reduce. Now we have definite integral from 0 to pi over 3. The longer one, which is the equation of the circle or the quantity, 3 times cosine theta squared minus the shorter r, which is the quantity of 1 plus the cosine theta all squared with respect to theta. Then we just simplify each term. The first one gives us 9 cosine squared theta. The second one gives us 1 plus 2 times cosine theta plus cosine squared theta. Simplify the integrand. We have a equals the definite integral from 0 to pi over 3. The first term, the cosine square, 9 cosine square minus cosine square now becomes 8 times cosine square theta minus 1 minus 2 times cosine theta with respect to theta. And the trig identity, the cosine square theta is 1 plus cosine double angle divided by 2. So this is 8 divided by 2 times 1 plus cosine of the 2 theta. That will reduce to be 4 plus 4 cosine 2 theta. 4 minus 1 simplify to be 3. So 3 plus 4 times cosine of 2 theta minus 2 times cosine theta with respect to theta. Lower limit 0, upper limit pi over 3. Find the antiderivative of 3 with respect to theta to get 3 theta. Antiderivative of the second term, we get 4 times cosine, which is the sine of 2 theta, divided by 2. 4 divided by 2 becomes 2. And minus, this term will be 2 times sine theta. Evaluate from 0 to pi over 3. The first group, 3 times pi over 3 plus 2 times sine of 2 pi over 3 minus 2 times sine of pi over 3. This quantity subtracted by replacing theta with a 0 to get 0 plus 2 times sine 0 minus 2 times sine 0. Sine 0 is 0. Sine at pi over 3 is square root 3 over 2 and sine of 2 pi over 3 is the same value, square root 3 over 2. 2 and 2 reduce, 2 and 2 reduce. Now we get, and also pi and pi, 3 and 3 reduce. We get pi plus square root 3 minus square root 3 and simplify to be just the pi as the area of the region outside of the cardioid but inside of the circle. For the figure provided at the end here is a nice looking one, so you can see the area inside of the circle but outside of the cardioid, and these two have symmetry with respect to the x-axis. The intersection point at pi over 3 and negative pi over 3, that means we use the reflecting about the x-axis, so which is the same as an angle 5 pi over 3.